Okay, so I know this doesn't look like your typical sum of cubes, different of cubes. But if you notice, can you take the cube root of 6? Basically, you guys, can you do this? You can, because 6 divided by 3 goes into evenly. So, the cube root of a to the 6th is a to the 3rd. I'm sorry, 6 divided by 3 is a squared. And so this would be b squared. Okay? So if it's a multiple, so if your exponent is a multiple of 3, listen, if it's a multiple of 3, then you can take the cube root of it. But it has to be a multiple of 3, like 6, 9, 12, 15, right? 6 is a multiple of 3. It goes into 2 times. So now what happened is now we have a sum of squares. The reason it's the sum of squares is because this is positive, this is positive. So now, believe it or not, my a is a squared and my b is b squared. So in the sum of cubes, the first thing that we do is we square a. Well, a squared squared is what? A to the 2nd power squared is what? What's 2 times 2? So this would be a to the 4th. Because remember, you guys, a squared times a to the 4th should equal a to the 6th. It does. Now the second term, if this is positive, this is going to be negative. And now to get the middle term, that center term, we're going to multiply a times b. Well, a squared times b squared is just that. It is a squared, b squared. Anytime you're dealing with the sum of cubes or the difference of cubes, no matter what, the last term is going to be positive. Always. It doesn't matter if it's the sum or the difference, that last term is always positive. And now we're going to do b to the, we're going to raise b to the 2nd power to the 2nd power. So b to the 2nd power squared is b to the 4th. So the reason we did that problem is to show you that you don't always have to have something cubed. You can still do the sum of squares, the sum of cubes or the difference of cubes with a number or with an exponent that is a multiple of 3. Now, if this was a minus right here, we could go further, but it's not a minus. The only time we could go further, again, is if this is a minus. Now, why I bring that up is because the next example, we're going a lot further than just that. So that's our answer there. We can't factor it. We're good like that, so we're done. But example 6 is x to the 5th plus 4x to the 4th plus 4x to the 3rd plus x squared y to the 3rd plus 4x y to the 3rd plus 4y to the 3rd. That is a big problem. How many terms do you have in this problem? 6, right? 1, 2, 3, 4, 5, 6. They all look like they generally have they look like they're grouped together perfectly. So we're going to group the first 3 together and we're going to group the second 3 together. So let's group the first 3 together. And then we're going to group the second 3 together. Okay. Now, what do the first 3 numbers have in common? Do the first 3 numbers have anything in common? X. So we're going to pull out an X. Oh, how many X's do they have in common? What's the smallest exponent? So we're going to pull out an X to the 3rd. which leaves me with x to the second, because x to the third times x to the second is x to the fifth, plus 4x plus 4. Now what does the second parenthesis have in common? Which is nice because look, those match, right? So a long time ago, we would think, whew, we're done with that problem. But because we're in Algebra 2, we're never done, right? So we have to look at different things. Well, that looks like it is a sum of cubes, right? X third plus y to the third. That is definitely a sum of cubes, which has nothing to do with the second parenthesis. So we're gonna factor this. So how do you factor x cubed plus y cubed? You're going to take the cube root of x to the third. So we're going to just work on this. So this becomes x plus y, because the cube root of x to the third is x, the cube root of x to the third is y. So that means my a is x and my b is y. So remember, I do a squared first. So what is, a is x, so x squared is x squared. This is positive, so this has to be negative. Remember, notice I keep saying that this is positive, this is negative, because these two should be opposites. Now we're going to do a times b. So what is x times y? And then we do b squared, which is y squared. So we factored the x cubed to the y cubed. That's this part. Now, can we factor x squared plus 4x plus 4? Is there two numbers you can multiply to get 4 that when you add them you get 2? You get 4. What are two numbers you can multiply to get 4, but when you add them you get 4? 2 and 2, right? So x plus 2 times x plus 2. Okay, so that is our final answer. The only thing that would probably even be better is if you wrote it x plus y times x squared minus xy plus y squared. So you guys, we got that again. Just a reminder, from x to the third plus y to the third. And then the only thing is this would be x plus 2 squared. You don't have to do that, although if you have Miss Zagolski next year, she would love if you wrote it like that, or Mrs. French Adams. So that is all of example 6. That is what we call extreme factoring. I know you guys can do it. Have a great weekend.